Hello to all, welcome back to my channel. This is Sangeeta. So today we are starting with the Pre-Cambrian of India. Okay. So I am going to start a series in which I'm going to complete the whole stratigraphy portion for BSc as well as MSc part. Okay. So it will be useful for your JAM preparation, for your GATE preparation as well as your GSI preparation. Okay. So before starting, let's see the geological time scale. So starting with the geological time scale. So before starting with the geological time scale, what is geological time? Okay, so this is the total time span of the earth from its origin. This is called geological time. And the available evidence indicate what is the age of earth. It is 4500 million years ago. And if we talk in case of billions, then it will be 4.5 billion years ago. Okay, so we can say it is 4500 million years ago or 4.5 billion years ago. Okay, both can be used. So it has been divided into eras, period, epoch, and this orderly arrangement is called geological time scale. Okay, and let's see the geological time scale which is drawn here. Okay, so this is what we are going to study today, Precambrian. Precambrian consists of Archean and another one is Proterozoic. So Archean is older than Proterozoic. So it will start like we will place the older one in the bottom one, then we will go for the younger one as we move above of this table. Okay. और अगर मैं हिंदी में बोलूँ तो जो भी ओल्ड होगा, जो पुराना सेक्सेशन होगा या फिर जो पुरानी फॉर्मेशन होगी, उसको हम नीचे लिखेंगे और जैसे जैसे यंग की तरफ मूव करेंगे वो हमेशा ऊपर लिखेंगे और हमेशा हम बॉटम से मींस ओल्ड से स्टार्ट करेंगे देन न्यू की तरफ जाएंगे. ठीक है. सो नेक्स्ट वन इज फेनेरोजोइक. सो ये हमारा क्या है, इयॉन्स है. ठीक है. नेक्स्ट इज एरा. एरा इज पेलियोजोइक. तीन है एरा, पेलियोजोइक, मीजोजोइक, देन नेक्स्ट वन इज सिनोजोइक. तो जैसे जैसे इवोल्यूशन हुई अर्थ पे वैसे वैसे पेलियोजोइक, मीजोजोइक, सीनोजोइक, ऐसे इन तीनों एरास में हमें डिफरेंट ऑर्गेनिजम्स, डिफरेंट प्लांट फॉसिल्स मिलेंगे, डिफरेंट इवेंट्स देखने को मिलेंगे. ठीक है. वो जैसे जैसे मैं इसको स्टडी करूंगी या फिर हम पेलेंटोलॉजी के पार्ट में आएंगे या फिर हम जब क्रेटॉन्स और शील्ड्स के बारे में पढ़ेंगे तब उसमें हम ज्यादा डिटेल्स में इसको बताएंगे. अभी वी विल ओनली लुक आफ्टर द प्रीकैम्ब्रियन एंड पेलोजोइक succession of India, Mesozoic succession of India, and Cenozoic because we are talking about the stratigraphy. All right. So next one is period. So period will consist of cos DSP. This is the trick to remember the sequence. Cos is Cambrian, Ordovician. Cos S Silurian, Devonian. Okay, so S is CP. ठीक है. This is Carboniferous consisting of Mississippian and Pennsylvanian. So Carboniferous have two categories. Bottom one is, which is older one is Mississippian in age. Okay. Next one is Pennsylvanian. Then DCP, P is Permian. Then we will move to Mesozoic era. Mesozoic era will consist of Triassic, Jurassic and Cretaceous period. Okay. TJC. If you want to remember it like this, you can remember. Next one is tertiary period consisting of Paleogene and Neogene. The next one is quaternary period. Okay. Next one is epoch. Okay. So epoch is Paleocene epoch, Eocene epoch, Oligocene epoch. So these all are epoch. Miocene, Pliocene and Pleistocene. So in the older one, we will write early, then we will write late, then again early for this Eocene. Okay. So in the middle, in the lower one we will write early, then as we move above it will be late. Okay. Sometimes it is written like this, so you need to learn this thing too, that where we should write early Paleocene, late Paleocene. So this thing will indicate this. So these are the ages written on the next of it. We will discuss these things later. So let's start with the Precambrian of India, which is our major task for today. This is written for your information. You can read them out. Okay, I'm not going in detail for this. I will make a separate video for this when we will study for this part. The last thing which is left for this table is, as we are going to study only the Precambrian part of India today, so I want to tell you the most important thing. Whatever lies below the 540 2 million years ago, that is Precambrian. Okay, so it will start with 4000 and will move up to 542. After 542, Cambrian or Paleozoic era will start. Okay, so now let's see this in the form of Indian map. All the Precambrian cratons and shield will be mentioned over there. Let's see that. We are going to start with the Dharwar craton, which lies in the south of India. Okay, and the other things which are mentioned over here, these are the Precambrian cratons like Aravali craton, Bundelkhand craton, Singhbum craton, Bastar craton, okay, Dharwar craton, and these darker portion, these are mobile belts. Eastern Ghat mobile belt, Pandian mobile belt, Satpura mobile belt. Okay, so let's start with the Dharwar craton. Okay, so starting with the Dharwar craton. Dharwar craton, it is of Archean age and it covers the peninsular India part, covering the area of 450,000 kilometers square. Okay, and it is bounded on the south by Pandian mobile belt, to the north by Deccan Traps, in northeast by Karimnagar granulite belt, in eastern side lies the Eastern Ghat mobile belt as you have seen earlier in the Indian map, and on the western side lies the Arabian Sea. Okay. So the most important things is about the rocks or the dominant soups which we get in this craton. So this is TTG, which is ternalite trondhjemite granodiorite gneiss. This is the exact question which has been asked in the GSI prelims part. Okay, so everyone remember that it is TTG, but nobody knows the full form of it. So this is ternalite trondhjemite granodiorite gneiss. Okay, this is the full name of this rock, which are collectively described as peninsular gneiss. Okay, and the second category of rocks which we get in Dharwar craton, it is greenstone or greenschist belts. Along with that, we will get the sedimentary association definitely, because due to some weathering, of course, some sediments will come along with that. Okay. So these greenstone belt together with intercalated meta sediments, these are called as Dharwar schist belt. Okay. We say these are schist belts, so it belongs to Dharwar. So we can say it is Dharwar schist belt. Talking about the trend, which is the regional trend of this area, it is north northwest and south southeast, which shows a gradual increase of metamorphism from north to south. Okay. So if this is Indian map, so as we move from north to southern part, the grade of metamorphism will increase. Okay. That is why we are getting gneiss and schist over here, which are high grade metamorphic rocks. Okay. These schist and gneiss gradually give way to granulites. Along with that, we will get granulites too here. Granulites are charnokites and chondrolite in the southern part of the craton. Okay. Okay, so starting with the stratigraphic classification, let's see this diagram first. This is very important. This diagram shows the essential features of Dharwar craton. So Dharwar craton is divided into two parts: Western Dharwar craton and Eastern Dharwar craton. Okay. So this whole portion, this is Eastern Dharwar craton part. Okay. And this part is Western Dharwar craton. Afterward, in the southern portion of it lies the Moyer Bhavani shear zone. This whole part is a shear zone. Then there is another shear zone which is Palaghat Kaveri shear zone. On the south of it lies the mobile belt which is Pandian mobile belt. This whole part is Pandian mobile belt. Okay. And this legend shows that what are the other basin and rocks which lies in this diagram. So this blue portion, is Kodappa basin. This green part, these all are granites. Okay. This pink part. This pink part is granite, and this white part here, these all are migmatite. This green portion, it is close bed granite. and this gray portion is charnocite. These purple ones, these are greenstone schist belt. I'm talking about the legends. And this yellow portion is peninsular gneiss. Okay, it is the same thing which is written over here, that the term Dharwar Craton was introduced in 1978 by GSI. Okay, and it is known as Dharwar Supergroup, Dharwar Greenstone Granite, and Shargur Schist Belt. So Swami Nath et al. Divided the Dharwar Craton into two tectonic blocks, Western and Eastern block. On what basis? On the basis of their character of schist belt, their relationship with the surrounding gneiss, and the grade of metamorphism, and their temporal evolution. Okay? And then later these blocks were designated as Western Dharwar Craton and Eastern Dharwar Craton. So the grey gneiss, which is of 2500 to 2700 million years ago, it was previously known as Peninsular gneiss, which covered the Eastern Dharwar Craton. So now the Peninsular gneiss is restricted to gneiss which is older than the 3000 million years, which are restricted to Western Dharwar Craton. Alright? पहले ऐसा बोला जाता था जो भी 2500 से 2700 मिलियन ईयर्स की रॉक्स हैं उनको पेनिनसुलर नीस बोला जाता था, बट नाउ जो भी पेनिनसुलर नीस है वो किसको बोला जाता है? जो भी नीस किससे पुरानी हो, 3000 मिलियन ईयर्स अगो से पुरानी है, जो कि वेस्टर्न धारवाड़ क्रेटॉन की है, उसको हम पेनिनसुलर नीस बोलते हैं. ओके, सो द ग्रेनेटिक टेरेन जो भी ईस्टर्न धारवाड़ क्रेटॉन की है उसको हम बोलेंगे धारवाड़ बेथुलित. ठीक है, जिसकी एज क्या है? 2500 मिलियन ईयर्स से ज्यादा है. और जो वेस्टर्न धारवाड़ क्रेटॉन है, ईस्टर्न धारवाड़ क्रेटॉन है, उसको एक शेयर जोन ने डिवाइड किया है, दैट इज चित्रदुर्ग शेयर जोन. इट इज वेरी इंपॉर्टेंट and it lies more on the eastern margin of the Chitrasdurga schist belt, which lies on the margin of close bed granite. ठीक है, see, this is Chitrasdurga shear zone which divide both eastern Dharwar Craton and the western Dharwar Craton, and it lies on the eastern side. मतलब ईस्ट साइड की तरफ ज्यादा होता है, जहाँ पे हमें ये ग्रीन पोर्शन क्लोज पेड ग्रेनाइट मिल रहा है, उस तरफ शेयर जोन थोड़ा ज्यादा है एज कम्पेयर टू वेस्टर्न धारवाड़ कटॉन, वही लिखा हुआ. ठीक है, I have told you that this Dharwar Craton is divided into two blocks, Western block and Eastern block. Let us see the differences which occur between them. ठीक है, so starting with the ages, Western Dharwar Craton, it is of 3000 million years ago, means it is bit older than the eastern part. Okay, and consists of gneiss with narrow belts and enclaves of 3300 million years ago, which is older than the Sargur group. We will see next in the stratigraphic table. Okay, and eastern block, it is of 2500 million years ago terrain, which consists of gneiss, and the most important thing, it consists of more of granites. Okay, younger granites with remnants of schist belt, which is of age 2600 to 2700 million years ago. Okay, talking about the metamorphism, so Western Dharwar Craton, it is of intermediate pressure. So intermediate, we will not get Andalusite, we will get kyanite and sillimanite. And eastern part, it is of low pressure metamorphism, so we will get Andalusite and sillimanite here. Okay. Next is in western part, we will get more of the gneiss, which is peninsular gneiss, which is of more than 3000 million years ago as per their age, and basement cover relation is there, which is best preserved. Okay, in the western part with angular unconformity, and which is with the Dharwar marked by the QPC. Okay, this angular unconformity will be having QPC, which is quartz pebble conglomerate. And in the eastern part, here you will get more the granites, so you will get huge igneous rocks of batholiths. You will get igneous rock in the form of batholiths here. Okay, Dharwar batholiths will be there, which is of 2500 to 2700 million years ago age, and it is intrusive on all the sides. And you will also see the diaperic gneiss domes here. Okay, talking about their lithostratic graphic association. So here in the western part, you will get quartz, arenite, metabasalts, BIF will be there, polymictic conglomerate you will get over here, Greyback submarine volcanic BIF association will be there. And in the eastern part, you will get more of cometite, tholite, amphibolite, BIF, metapelites, quartzite. Okay. Next is submarine bimodal volcanics is visual over here. And another one is immature plastic sediments will be seen here along with BIF and felsic volcanics. So here the last part. In the western block, of course, we get large schist belts over here. Okay. With volcanics and subordinate sediments, example Chitradurga, Shimoga and Babubudan. Okay. And in the eastern part, you will get narrow linear belt. Okay. These are narrow over here, and schist belts are more larger on the western part. Okay. And below basalt is visible here, along with Kolar, Kadiri Hatti, Ramagiri, and Veligalu, Raichur, and Gadwa. Okay. If we study about the details of Western Dharwar Craton, so Western Dharwar Craton, it is also called as Karnataka nucleus, which is given by the Radhakrishna and Naqvi, and is grouped into two orogenic cycles which are separated in time. Okay, and the older one is Sarguru group. This one is Sarguru group. Okay, and the next one, which is younger, it is of this age, 2600 to 2800 million years ago. This is Dharwar supergroup. Okay, this is older one and this is younger one. Chalo. Next one is this Dharwar supergroup is regionally correlatable and exhibit coherent stratigraphy. Okay, whereas the Sargur group is represented by disarrayed enclaves of diverse rock type exposed in the same locality. Means in Sargur group you will get diverse variety of rocks. In Western Dharwar Craton, it will be mainly consisting of peninsular gneiss, as I have told earlier. It will comprise of TTG gneiss, which form the basement to Dharwar supergroup. Okay, and there will be another one contact regional unconformity will be there, which will mark the cessation of Sargur orogeny. Okay, so this unconformity, I will explain this table. This unconformity will tell that Sargur group is going to end over here. Sargur group orogeny is going to end over here. Then Dharwar orogeny will start. Okay, Dharwar formation will start. Next, of course, as I have told you earlier, this unconformity will be of QPC type. Okay, quartz pebble conglomerate type, which is uraniferous. This is important. Also, narrow linear belts are there. Next is, okay, so in Western Dharwar Craton, there will be two prominent superbelt, okay, or schist belt. This is Baba Budan and another one is Chitradurga. Okay, so these greenstone belts of Western Block, they are characterized by supracrustal rocks, dominantly consisting of mature sediment with subordinate volcanism and intermediate pressure. As I have told you earlier, that in Western Dharwar Craton, there will be intermediate type of pressure of metamorphism. Okay, which is Barrovian metamorphism. Okay, so this is the regional stratigraphic division of Western Dharwar Craton given by Swaminath and Ramakrishnan. Okay, you will get these table in both the books. So in the basement part lies the Gorur gneiss, which is of age 3300 to 3400 million years ago. You need to remember the ages. So in the bottom part lies the Gorur gneiss, which is of 3300 to 3400 million years ago. Okay. Then there will be an intrusive or tectonic contact. Then there will be one group which is Sargur group, which is of 3100 to 3300 million years ago. Okay. And the rocks which it will contain ultramafic layered complexes. Okay. Tholites, amphibolites, cometites will be there. BIF will be there because in Archean we get mostly cometites, right? So that is why cometites is written over here. BIF is also there. Quartzite, then silicate rocks are there. Then again there will be another intrusive contact, and the next thing which we'll find after this is peninsular gneiss, which is of age greater than 3000 million years ago. Then after this lies the deformed angular unconformity. Okay, so this unconformity will mark the cessation or the ending of Sargur group, and after this, what will get deposited? The whole succession of Dharwar supergroup. So Dharwar supergroup will be consisting of Baba Budan group. Okay, and Baba Budan group will be having formations like Kalsapura formation, Alampura formation, Santaveri formation, and Mulingiri formation. And these are the rocks which these formation contain. In the Kalsapura, mostly metabasalts are there, gabbro, schist, phyllite, and in Alampura we get metabasalt, cross-bedded quartzite. Santaveri also contain metabasalts. Mulingiri, BIF with chloritic and graphitic means or schist. In Chitradurga group, Vanvilas formation is there, Ingaldhar formation is there, Hirur formation is there. Okay? And these are the rocks. Okay, so starting with the Gorur gneiss, let's see them in detail. So Gorur gneiss, it is the oldest gneiss of age 3300 to 3400 million years ago in the western Dharwar Craton. It consists of suit TTG gneiss. Okay, and the relationship of Gorur gneiss with Sargur enclave is uncertain. And next one is Sargur group. Here lies the narrow linear belts like Hole Narsipur, Nugihalli, Nagamangala, okay, which occur as rafts within Gorur gneiss complex of Sargur group in western Dhar Craton along a intrusive contact. And the lithology is ultramafic layered complex are there. Tholites are there, amphibulites are there, cometites, very important. Okay, you need to write this. BIF, quartzite, phyllite, marbles, and calc-silicoid rocks are there. And they are comparable to true greenstone in having rocks with high mafic and ultramafic component. Okay. Next one is Dharwar supergroup. It is divided into two groups like Upper Chitradurg and Lower Bababudan. Okay, this one. Lower is Bababudan and upper one is Chitradurg. So the supergroup is exposed in two large schist belt that may be called as super belts. Okay, these are schist belts. And if we discuss briefly about the lithology of these schist belt, Bababudan group or Bababudan schist belt, it is crescent shaped belt occupying the area of 2500 square kilometer in Bababudan region of the Karnataka state. Okay, so it has a normal contact in south, which is marked by the basal QPC quartz pebble conglomerate and resting mainly on the basement consisting of TTG gneiss and Dharwar supergroup. The schist belt comprise mainly of basaltic volcanics and a range of detrital and chemical sediments. If we talk about the formation, it consists of four formations: Molengiri, Santaveri, Alampura, and Kalsapura. These lower three formations, it is dominated by amygdaloids and massive tholitic metabasalts. Then if you talk about the Chitradurga schist belt, this is the one of the longest greenstone belt, okay, which is of 450 km, where volcano sedimentary sequence of large span of geological times are preserved. ठीक है, और ये extend कहाँ करता है? Extend from Gadag in north to Mysore in south in north-south direction. ठीक है. This schist belt is consisting mainly of the bimodal volcanics, means mafic and felsic rocks will be shown over here. Pillow basalts are there. ठीक है, important. And it is divided into three main formations. This Chitradurga group: Vanvilas formation, Ingaldhar formation, and Hirur formation. ठीक है. So Vanvilas formation, it will be corresponding to volcanic formation consisting of manganese and iron formations. Okay. It is followed by Ingaldhar formation consisting of bimodal volcanics again. Okay. And the Chitradurga supergroup is intruded by Chitradurga granite, जिसकी एज क्या है 2600 मिलियन ईयर्स अगो. which gives younger limit of Dharwad sequence. Here, Chitradurga granite will be the younger one. Next is Eastern Dharwad Craton. So if we talk about the eastern part of the Dharwad Craton, so eastern part will contain Yashwantnagar formation, which is equivalent to Baba Budan group, and Kolar group, which is equivalent to Chitradurg group of the Western Dharwad Craton. Okay. So Eastern Dharwad Craton is characterized by volcanic dominated and it is sediment poor, gold rich greenstone deposits. In contrast to Western Dharwad Craton. Okay. We will get gold rich greenstone belts here, which were not found in the western part of the Dharwad. Also, you will get many younger granitoids here. As you have seen in the previous diagram, the whole pink portion was granites. Okay, so Eastern Dharwad Craton is full of granites. Okay, so basement cover relationship is not present in the Eastern Dharwad Craton, which was present in the Western Dharwad Craton earlier. Okay, and the linear arrays greenstone belts of Eastern Dharwad Craton are called super belts, usually like the Yashwantnagar formation of Sandur belt. Okay, you need to remember this. Sandur belt, it has similarities with Baba Budan group. Okay, and Kolar belt, it is regarded as the type area for the rocks of Kolar group. So it is considered as type area of eastern greenstone belts and has been correlated with Chitradurga group of Western Dharwad Craton. Okay. Up at the eastern margin of belt occur a prominent horizon of felsic, volcanic and volcanic plastic suit of champion gneiss. Okay. This is very important. Champion gneiss is present over here. And these are the prominent greenstone superbelts, Ramagiri. Okay, these superbelts are there, Kolar, Hatti, Veligalu, Raichur, Gadwal. Okay, and this is the table for comparison between both Western Dharwad Craton, as I have told you earlier, and Eastern Dharwad Craton. So the whole thing is marked by one granite, which is close-packed granite. So close-packed granite is marked by the granitic intrusion, which will reflect the end of Dharwad cycle. Okay. This belt of younger potassic granite. Okay. This close-packed granite is it is of which composition? It is a potassic granite. Okay. K-rich granite, which mark a major geosuture of or joint between two distinct crustal blocks, Western block and Eastern block. Talking about the life, the stromatolite is found over here, which is Betiola indica. It has been reported from the sediments of Chitradurga group. Okay. And if we talk about the mineral potential, so Western block, it is mainly characterized by the mineralization of copper, iron, manganese, okay, along with the minor gold. And iron ore is found in the Kudremukh. And important gold deposits are here, which is Kolar, Ramagiri, Penakacharela, Hatti, and Maski in Eastern Dharwad Craton. And they are also known for iron and manganese mineralization. So this was all about the Dharwad Craton. In the next part, we will start with the Budappa supergroup. Okay. So till then, do like, share and subscribe. मिलते हैं next video में. Bye.